Last class we started to discuss about the shingling. Am I correct? And most of you understand the shingling, right? I think, okay, this example most of you understand, right? So now the problem where it is coming, the problem is going to be comes over here. We understand the both the discussion, the Jacquard similarity and distance. Then after we understand the form Boolean matrix, the singles and documentation in the last class we discussed. Shall I start from the first onwards, or I can start the mini hashing only? Hello, am I audible? Aryan?
Yes, sir.
So shall I go? Mini hashing, or can I come from the shingling?
Sir, you can revise once shingling, then we can start with mini hashing.
Okay, but it means okay, you require complete discussion. But you said okay, 5:15 is your time. Right? Okay, I will go with the complete discussion, है ना? So that okay, we'll get to know okay what is the locality sensitive hashing with an example, है ना? So what is shingling? We understood. The simple point here need to be observed. You have a document. In the document, how many strings are there? What length of strings are there? We need to be find. That means okay, we need to find the similarity. So the main discussion is going to be in the third chapter, completely based on the similarity only. So what is our target here to understand? Our target is to understand, okay, similarity. This one only. So you clear now? So that means whatever the documents you have, you need to be find the similarity of the documents, right? So if you want to achieve that, first we need to be understand the duplicates, where the duplicates are there. So the duplicates are going to be, the duplicate is going to be two types, we can say. A direct duplicate and nearby duplicate. Example, suppose you have A, B is there. And there is another place also A, B, C, it may appear to you. What we can say, these two are same or different? Anybody can answer for me?
Different.
Absolutely, these two are different. These two are not same. But what we can say, this string is near to this string or not?
Yes, sir.
That's why the documents are going to be two types: duplicate document or near duplicate document. According to the web crawling, you need to be observed, so okay, duplicate and near duplicate documentation. So we need, but our main aim of this discussion, the big picture, whatever here it is there, the main aim of this picture is going to be, we want to check the similarity. If we want to check the similarity, how, or okay, what I can say, my question is, okay, what question we need to be placed in front of us, that is, what is the right representation of the document when we check for similarity? Right? You are checking for the similarity, but what is the representation? What is the right representation you have to be choose to check the similarity? So suppose if you go and represent a document as a set of characters, are you able to achieve the similarity? No, you are unable to. Why? Because you have like so many documents, out of so many documents, so many characters are there, and it requires a lot of memory to perform this particular operations. So what we have to perform, always we have to perform a pairwise comparisons. Means, okay, this is mine, okay, this is comparing with the other one, this was same, then this document same, you can keep it in one place. Clear? So such a way that we have to go and we have to try to find, okay, this particular, okay, that means, okay, we will try to find the similarity. In that case, so first we need to be understand about the shingling. Shingling means, how do we understand? Very simply we will understand, that is, take a k contiguous characters, means, okay, k characters. K shingling means k characters we need to supposed to be two. K characters, okay? In the k characters, suppose I can write like this. Suppose, okay, simply I can write. Oh, here, okay, I am unable to. So I would like to, okay, share mine. Sorry, I'm going for my screen. Please let me know both the people are able to see the screen or not. That is important for me, because I am creating my whiteboard. The whiteboard is visible to both of you or not? Please, one of you answer for me.
Yes, sir.
Thank you. Both of you are able to see this, okay, the whiteboard. Then I would like to say how a shingles we can develop. The first discussion for us is going to be to, okay, develop the shingles. So that's why we need to write set of shingles. Set of shingles. So set of shingles, suppose I need to be supposed to be right. How I supposed to be right? Like this. Arrows is, suppose I can keep the text color is going to be red for your, okay, representation point of view, need to be keep it, okay, and you can write like this also. This is another pattern, but the same characters. Oh, it is not changing, okay, like that. Right, okay, no problem. I can try. Right. Next, I can write. This is another pattern. Right. It's another one. So now you try to understand one thing. Here I would like to represent with the different colors. This is going to be one color line. This is going to be other line. This is going to be another line. And this is going to be another line. So likewise, how many you are able to write? You can able to write 9 different, okay, 10 different, okay, patterns like this. Am I correct? Are you agreeing with me? Now, I want to represent these values with a set of 64-bit integers. That is my first, okay, task under this shingling. Right? So because of this, what I will do, I will map these two different 64-bit okay, values. 64-bit integer values. Am I correct? So what are those? Okay, suppose I can write here 1 1 1 1. That means, okay, if you're using a 4, okay, that means, okay, 4 bits to represent this particular, okay, pattern. So how many of, okay, that means, okay, values are required that are from 1 1 to, you have to go continue like this. What are they? All 0 0 0 0. Means next one is going to be 2, 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4. Fine. So that's why what we need to do, we need to be understand about how to, okay, that means, okay, develop this hash values. So that, okay, we need to be understand the basic, okay, models are going to be your Jaccard similarity, Jaccard, okay, distance we discussed in the class. The same thing we will use to, okay, develop this one. After that, what we supposed to be do? Means here, what is the required? We require to compute the Jaccard similarity as well as the Jaccard okay, distance. Then after, the main idea is going to be here, it is going to be, that is, we have to be develop a signature for each and every pattern. That we can call it as a signature. So that signature set also we can say that the hash of each set means, okay, suppose, okay, I can say rows is this one, such a way that how many, okay, documents are there, that documents I need to be keep it, okay, attached to this one, 1, 2, 1, 4, 7, like this. All the documents consist of this rows is like that. I can keep it like that. After that, I need to be develop a signature. So this signature, we can fit as a signature, we can fit this into the main memory of the system. So in the main memory, so we have to be developed for each set, we have to develop a signature, and we will keep that signature, and we will preserve that signature for the similarity point. But what happens here, sometimes, okay, we need to be, suppose if you need to be observed here, clearly you may observe or not, what is the difference between this one and the next one? Any difference is there? Anybody can actually please tell me? Any difference is there between these two? Rows is here, rows is here.
No, sir.
Absolutely, we are unable to find, okay, no difference, no, but there is a difference. That's why we are keeping these two are different sets. Okay, here you observe, this is the starting, okay, point. Na? This is the starting point. Am I correct? If I may correctly draw this one, this is the starting point. What is this one? What is this one we can call it as? That is a white space. Your computer is going to read, your white space is also going to be character. Because of that, the k consecutive characters, if it is same, that it means you need to be choose that the white space is also going to be a character. Is it fine to all of you? Understand?
Yes, sir.
All of you understand? Means a white space, comma, some other, okay, small things will be also comes into you, so that, okay, whenever you go for similarity, you have to be take that also into the count. Because of this, the finally we need to be understand, okay, we were identify the signature in the sense, suppose, okay, we are, okay, comparing two documents. Okay, signature if you created, which means that is just small enough that we can fit a signature in main memory for each set. The second one is the similarity of any two documents, means you are going to check it out. The signatures you need to be verified. If the signatures are same, then the similarity of the signatures are going to be equal. If similarity is not same, which means the signatures are going to be different. In that case, we will find, okay, two different activities. One is false negatives and false positives. What are those? False negatives and false positives. What is a false negatives means? We are going to use the similar items, but that are deemed to be a non-similar. False positive means you are treating the items non-similar, but that are similar. So Are you getting my point? What we need to be understand here in the two discussions? False negatives and false positives. False negatives and false positives. So you understand what is the meaning, what is the difference between these two? Anybody can tell me? False negatives and false positives. Example I would like to take you. Suppose A, comma B are two documents are there. These two are different, but you are treating these two are similar. Means B is not A, but you are treating B as B is equal to A, which means what? This one. You are treating B as A, but it is not. This is going to be comes under false negatives. What is false positives? Here you have A comma A, but you are saying this is not similar. Understand? Are you okay with this? Okay, false negatives and false positives. Right. Next, okay, we discussed the same every time. Okay, that we discussed in the last discussion. We need to be construct a Boolean matrix. The Boolean matrix is going to be consisting what? Rows and columns. Columns are going to be your singlings, and rows are going to be your singlings, and columns are going to be your documents. Right. Are you okay with this? Hello? Just a minute, I can see, otherwise anyone. Hello?
Your voice is lagging.
My voice is lagging?
Yes,
Okay.
sir.
No issue. Then okay, we will discuss second thing here. We need to be go ahead with the Boolean matrix. The Boolean matrix, the last time we discussed in the Boolean matrix. So here you need to be observed. We discussed this Jacquard symbol and all. This is the Boolean matrix. Am I correct? The similarity C1, C2, we are representing either 0 or 1. Right? And we understand that this particular size of intersection is going to be 3, size of union is going to be 6. So Jacquard similarity, we discussed. How we discussed about this one. Here you observe, suppose this one you may take, and this one you may take. Okay, what is the intersection for this one? The intersection, you should be understand, this is 1, this is 1, this is 1, this is 1. So how many intersections are there? 2. And observe, okay, like that any are there? Here, okay, another one. So 3 intersections are there. That's why we written here is this is. So here this is going to be our C1, this is going to be our C2. So size of union. How we need to be count size of union? This is one row consists 1. This one row is also consisting 1. This row is also consisting 1. But this row doesn't consist anything, so that okay, we are not counting this one. This one is also consisting 1. This row is consisting 1. This row is also consisting 1. Either C1 or C2. If it is 1, you can treat that as a part of your document. So such a way that you may go ahead. How many are there? 1, 2, 3, 4, 5, 6 are there. That's why the union value is going to be 6 more in the Boolean matrix. That means okay, your rows are going to be shingles. That will be written here the shingles, and the columns are going to be documents. That is going to be a document. Right?
Yes, sir.
Then fine. Now I am going to that. Now we are calculating the Jaccard similarity. We have okay, Jaccard similarity formula. What is the Jaccard similarity formula? C1 intersection C2 divided by C1 union C2. Am I correct?
Yes, sir.
That the distance is very simple, 1 minus Jaccard similarity. So that okay, you will get a 3 of 6. Okay.
Yes, sir.
So now I have to go for the next to discuss about this. So now, okay, any doubts on this particular? Okay, any doubts on this Boolean matrix construction, Boolean matrix? Okay, discussion.
Sir.
Thank you. I'm going for this. Okay. Next goal to find the similar columns while computing all signatures. So we discussed about this one also, hash similarity and signatures we discussed. Hash column. This is also we completed. Now we are coming to the mini hash function. In the mini hash function, which we need to be understand, okay, how we have to perform a small activity. This is your input. And last discussion we made, the main point here we need to be understand, that is this random permutation. So random permutation and pi only. What is a pi? Pi is going to be your column value, your shingling values. Your shingling values. Suppose I would like to go this one, and I have to be okay, perform this one 2, 3, 7, 6, 1, 5, 4. So random permutation. Random permutation of what? Your shinglings. What shingling values you chosen previously in the discussion, you might go. We discussed about the shinglings. Okay, in the shingling, what values we need to be choose for the hashing? 0 to 9 only. Am I correct? Where is it? The discussion. I think hashing, no? Bit vectors we discussed, and the mini hashing. Before mini hashing, what we discussed? We discussed okay, the similarity. Then after hashing point of view, somewhere okay, we discussed okay. Hashing is there. In the hashing, how many values we required? We required 9 values, 0 to 9. Previous discussion you might discuss. Okay, all patterns are going to from 0 to 9. Why? Because we are using a hashing. Okay, why we need to be using hashing? Because what we can say here clearly, instead of using shingles directly as a shingles, you can use or you can pick your hash function. That hash function is going to be maps strings of length k to some number of buckets, and treat the resulting bucket number as your shingling. Resulting bucket is number as shingling. So the same way here you observe these 2, 3, 7, 6, 1, 5, 4 are going to be a random, random permutation. What random permutation? Okay, you have a rows of your Boolean matrix. That rows of Boolean matrix we need to be permuted under a random permutation. So suppose you have here the shingling values. Suppose here shingling values are there. Each row consisting some value. That values you need to be randomly permitted. Randomly permit that values. Okay.
So like hash values are permitted.
Yeah, we are going to be permit the hash values of that. Clear now?
Yes, sir.
So now what we are doing here, okay, this is one random permutation. The corresponding random permutation is going to becomes like this. The signature of the matrix we are computing. Okay, 2, 1, 2, 1. Right. Again, you have to go for this is the second element of the permutation. Second element of the permutation is the first to map to A1. here 1 is there and here 1 is there. You have to be, that means okay, your shingles versus documents you need to be used and you need to be mapped or corresponding to that one. Next one you need to be choose. Again, what values are there now? Now again you may observe here. So here where is the 4? 4 is the last one. What is the last one? And again you need to be, while okay, this random permutation among these particular values only 2, 3, 7, 6, 1, 5, 4 is there. The same values are going to be randomly be permitted again. Are you understand now? The random permutation, just we are performing on the shingling values only, shingles values only.
Yes, sir. But sir, how the permutation is related to signature? Sir.
Permutation is going to be lead to signature. That you need to be observe over here. Mini hashing and the signature. You need to check here. This is the signature idea. What is the signature idea? You need to be observe over here. Hash each column C to a small signature H of C such that H of C is small enough that the signature fits in RAM. If not, okay, then we go to similarity of C1, C2 is the same as the similarity of the signature H of C1 and C2. The goal is going to be, you have to be find this way to develop your signature of H of C that. So hash documents into the buckets except that the most pair of near duplicate document hash into the same bucket. So that is our main motto over here. So that's why we need to be find. Okay, we need to be find the similarity. Is high or low? If high is there, okay, what is the probability? And low is there, what is the probability? That's why here we need to be go for okay, to find the Jaccard similarity and there is a suitable hash function for the Jaccard similarity. It is called the mini hashing. So we are doing that one, and with help of this, we are computing this hash values. We'll see. It will come in the discussion. Further discussion also, we will observe how this particular values are coming to us. Now you need to be observed. The fourth element of the permutation is the first to map to a 1. Here, first element we mapped to first one. Right? Here, what we need to be go for? The fourth element. 4 is there. That one we need to be fourth element of the permutation is the first to map to a 1. And we are doing this for what? We are doing this particular row only. First row only we are doing. We are not doing for another rows. Please be remember, for the signature matrix, we are computing for what? The first row only. How many of you understand? Any questions? May I get some questions from you?
So it says second permutation of the second element of the permutation is first to map to 1.
Yes, correct.
So then which one is the second element and where we are mapping it? Like, this is not clear.
So suppose I would like to give you simple example to make you to understand with some numerals, so that you will get to know in a better way. Small example I would like to take, and I would like to provide it to you to understand something. So what I would like to do, again I am going to my, where is my this one. Okay, I'm going to my whiteboard. Listen. Sir, class sir, call me. Huh? Okay, sir. Class లో ఉన్నాను సార్, మళ్ళీ కాల్ చేస్తాను. Hello. So just an example I would like to give you to understand what I need to do. I need to go for a small example. Okay, please try to understand this one. First, okay, I need to be develop initial input matrix. Initial input, our okay, matrix. In that case, suppose I may take some A, B, C, D, and E, F, and G, suppose. The matrix is look like this. This is okay. I can write okay S1, S2, S3, S4. Okay, these things. So now the values are like this: 0. Or against of 0, I can take it 1. Better actually. 1, 0, 1, 0 is there. Perfect now? And the next one is going to be 1, 0, 0, 1. Third one is going to be 0, 1, 0, 1. And D is also going to be, this is A, this is B, this is C, this is D. Right? 0, 1, 0, 1. And E is also 0, 1, 0, 1. And F is 1, 0, 1, 0. G is 1, 0, 1, 0. Now tell me what we require. We require a random permutation. Am I correct? So random permutation means what we need to be choose?
Hash values for singles.
Shingles are there here. What are the shingles? A, B, C, D, E, F, G are there. Okay, I have to take randomly. So I am taking A, some C, some G, some F, then B, then E, some random value, whatever. I'm just taking a randomly, some E. What else is missing now? A, C, G, E, B, E missing. One more is missing, that is, I think D. D is missing, right?
Yes, sir.
D is missing. I can choose D. Am I correct? Right?
Yes, sir.
Now I have to compute. Now I have to compute. Two things I need to be compute. Right? Here, what value is this? Suppose I may write A value. What is A value here? You have 1,
1, 0, 1, 0.
0, 1, 0. What about C value?
1, 0, 0, 1. Sorry, 1,
0,
0, 1, 0, 1.
0, 1. Am I correct? Are you okay with this?
Yes, sir.
Now you have to be represent this one with, okay, what is the signature for the resultant one for this? For these two only you need to be looking to this. For these two only you need to be looking to. This is 1, 0, this is 0, 1, this is 1, 0, this is 0, 1. So can we, okay, that means, okay, can we represent this one? A is 1, suppose, okay, C is 2, suppose you may take like this, we can write this is going to be 1, this is going to be 2, this is going to be 1, this is going to be 2. Suppose, for example, I would like to come to you, another random string I may take. Another random string I may take. Right?
Sir, so basically the permutation was the whole matrix was permuting.
You are okay. Whole matrix, okay, row by row, you have row randomly you are permitting.
Okay, sir, I got it now.
Got it?
Yes, sir.
Then the values you need to be representing.
Yes, sir. Then we are counting where the first one in the
Yes, perfect.
column is. Yes, sir.
Suppose another example I would like to give you so that you will get to know very easily to understand, okay, how this, okay, values are going to be computed. Suppose I may take another thing. Suppose, okay, random string is going to be there here. Another random string, that is D, B, A, C, F, G, and E. Suppose like this is there. So now what you supposed to do here? What is here? This is D, correct? D, how can you represent?
0, 1, 0.
So here you need to be take a D, B corresponding 0, 1, 0, 1. So you need to be take 0, 1, 0, 1. Am I correct? So you need to go for B also. 1 minute, I am. Sir, I'm in the class. Sir. Can I call you back? Huh? Online class. Thanks. Bye. Okay. So next, what we need to supposed to be write? B. What is the B value? 1001. 1001. Right. Next, what value is there? You
1,
have
0, 1, 0.
A value is there 1, 0, 1, 0. Now you can suppose you may take these three. What is your okay output value?
2, 1, 3, 1.
2, 1, 3, 1. That's all.
Yes, sir.
Fine now. Absolutely. Got it, everybody? Understand how we are doing this, okay? Signatures and mini hashing, how we are performing. You try to understand from this particular example. Suppose here, suppose okay, we have okay, suppose you are comparing two values from, suppose okay, there is another pattern is there. Suppose you may exercise for that another pattern, C, D, G, F, A, like that. So you may compare any two values. Suppose okay, C and G value. What are the values will come? Can you do it? C and G value. What is the resultant? C is what here? 0, 1, 0, 1. What is D value? Again 0, 1, 0, 1. What is D value? 1, 0, 1, 0. What is the resultant value? Now what values you need to be supposed to be choose? This one. That means here. What is the one here? Is it one here?
Yes, sir.
One. Okay, I'm coming back. Now you observe, okay, this okay, how we are going to be, what is the resultant value over here, okay, we will receive in that case.
3, 1, 3, 1.
That means, okay, you need to be checked for the C, where is the first one? Where is the second one? Right? And here also you need to be verifying, where is the G point of view, what is the first one and second one?
Yes, sir.
Here the first one is where? Here, and the second one is here. Now tell me what value it will come.
3, 1, 3, 1.
3, 1, 3, 1 it will come. Simply. So now, if suppose these kind of random patterns you are going to be chosen, if you are going for a signature computation, in the signature computation, what value we received? Initially, what value we received here? 1, 2, 1, 2. Correct?
Yes,
Here,
sir.
what value we received?
1, 2, 1, 2.
2, 1, 3, 1.
Yeah, 2, 1, 3, 1.
2, 1, 3, 1. So this is okay. 1, 2, 1, 2. This is 2, 1, 3, 1. And last one is going to be 3, 1, 3, 1 here. 3, 1, 3, 1. So these three signatures, again, you need to be used and you need to be compute the values of the signature. Right? So now you need to be calculate the signature 2 value. How do you calculate signature 2? Vector of hash values, you need to be used for that vector of hash values. So that's why you require, okay, what is the ith hash function of the set S? The S2 means ith function of the S2. Based on that, you need to be calculate your signature. I think, okay, most of you understand how many hash signatures we are performing. Perfect. Hello. So simple here. If you hash function property, you need to be go ahead. You have to use the probability of h of s1, h of s1, right? Which is going to be equal to h of s2. H of s2 is going to be equal to, you need to be write it down the similarity of s1 and s2. Similarity of s1 and s2. So here what we are doing, the probability of overall choices and the permutations we are taking and we are computing the similarity of that particular function. Are you understand? Shall I give some other example to you to understand about this particular property?
Yes, sir, I got it.
Shall I move?
Sir, can you explain once again 2131?
Which one?
2131 example.
2131 example. So now you have to take. Okay. What is your this is the first one you need to be take. A, C, G are there. You have to compare A and C, and the first where is A is coming that you need to be observed, and after that you need to be write the corresponding values over here. Correct? This is fine. This is one. This is one. This is okay. 2. This is 2. That's why we written 1, 2. And here you observe. We are comparing D, and here another is going to be B, another A.
Okay, sir.
Got it now? Hello? Are you understand or not? So first you need to be observed. Which one you need to be select? Which one you need to be select? Here, this is the first D, 1 is there. So that's why it's 1. Here, first one comes in the first row is 1 here. That's why 2. Right here, it's first one is going to come for the A, 3. And here, you need to be used for D, then this is going to be 1.
Okay, sir. Got it.
Got it?
Okay, sir.
Clear? The combinations we need to be observed. Where the column values, which column values you need to be select for your hash, that you need to be understand. This is just you need to be map for that, and you have to go ahead with that. Any questions? Please.
No, sir.
Okay, thank you.
No, sir.
So this is what about mini hashing. Suppose you need to be take 3 signatures like that, the same way in the slides we are performing here. What we are doing, just you need to be observed. Here 2 means you need to be take the second values, right? And 4 means you need to be take the fourth one. So and so on. You need to be get it down like this. So this is the way you may go ahead. You need to be develop another equivalent way is to store the row indexes values. Then this is the only I explained you. Just the probability of first column, which is going to be equal to the second column for the random permutations. That you need to be treated as your similarity of C1 and C2. We have chosen a random permutation and we are going to be claim this one. Why we are claiming this one? if you have some document, let X be a document and Y is going to belongs to a shingle. Clear? Y is going to be belongs to a shingle. Then the probability of pi of Y, which is going to be equal to min of pi of X, which is going to be equal to 1 divided by the length of the X. That is going to be our set. So that Y is belongs to X, which is going to be mapped to the minimum element. Right? Let Y be such that the pi of Y, which is going to be equal to min of pi of C1 union C2, so that we can compute pi of Y is going to be min of C1 if Y is belongs to C1, or pi of Y we are going to take if it is going to be min of C2, and Y is belongs to C2, such a data. So the probability that both are true in the probability Y is belongs to C1 intersection C2, so that the final similarity is going to be C1 C2. That it means what we are saying, we are climbing this one. How we are climbing this one? We are proving this one with help of this particular theory. Are you clear now? Shall I move to the next slide? So now we need to calculate the similarity of the signatures. The similarity of the two signatures is the fraction of the hash functions in which they agree. Fraction of this meaning you need to keep it. Why? Because again we are going to calculate the signature. Why? Because we already signature matrix is there. From that we need to go for a similarity of two signatures. We need to calculate that we are discussing right now. Now you need to take these are the signatures we received. We need to take the similarities of the 1 to 3, 2 to 4, 1 to 2, or 3 to 4. We are calculating the similarities. The similarities are like this. Fine. Shall we continue or shall we stop here and we'll go for the next class to discuss about the locality sensitive hash? So that time I will explain this one also to you to make it you understand. That's why it takes 1.5 hours plus to explain about the whole locality hashing discussion.
Sir, we'll take locality hashing next class.
Next class, better now? No,
Yes.
no. The point is, I have few questions. Please try to answer for my questions. I'm sorry, your time I'm killing. Why? Because this is what is called snacks time, na?
Yes, sir.
I'm sorry for that. So try to here I need to be in the chat box. Please provide how many of you understand both shingling and min hashing. Say yes or no. Honestly say, no issue. We will repeat the same discussion in the next class to make you to understand. Honestly, if you may put, I would like to try to reach you with another suitable example which is going to be very easily understand by everyone. Oh, min hash partially. Okay, right, good. That kind of feedback is required for us to make more better way the exam. Why? Because these are the very important discussions. Because data science is one of the that means the job provider for you. Okay, correct? These are all very advanced topics. So that you need to understand these topics that enhances your job opportunities. Because of that. Only 2 people answered for this. May I get few more few more answers? So that we'll conclude this class and we'll go, huh? Yeah. So again, okay, before I'm going to be start this locality sensitive hashing, I would like to give a little bit brief, but I don't want to take too much discussion. I will take 5 to 10 minutes to again, okay, give this to small information to you, right? So our ultimate goal is going to be, you have to be understand these concepts to apply in some way actually. Excellent. Okay, thank you all. We'll go to this locality sensitive hashing in the next class. That might be on Monday here evening.